Well, here we have a couple of exponential problems to deal with. So number 1, 3 to the 7x equals 3 to the x minus 9. And as you know, that if the bases are identical, you can simply equate the exponents. So that's what we're going to do. So 7x equals x minus 9. If we subtract x from both sides, we get all the x's on one side, everything else on the other. Now let's multiply both sides by 1/6 and 1/6. And the 6's divide out here, and we get x equals minus 9 over 6, which reduces to 3 goes into 9 3 times and into 6 twice. So there's our solution. Now let's deal with number 2 here. And that's 4 to the negative x equals 7. Well, now we've got a different situation. Notice the bases are not identical. But we can employ the law of logs and take, for example, the natural log of both sides. And if we do that, 4 to the negative x equals ln of 7. Now by the law of logs, we can pull this negative x out in front, and we have negative x ln of 4 equals ln of 7. Now let's divide both sides by negative ln of 4, negative ln of 4, and those divide out, and the negatives are going to divide out, and we're left with x equals, we'll stick this right out in front, ln of 7 over ln of 4, and if you were to run that through a calculator, that's going to be approximately negative 1.40. And but this is the preferred answer. This is exact up here. Here's the approximation. Now listen, I have one more we're going to do, and that's number 3, and it's e to the x is greater than 53. And we've got the same problem here that we had there, and that's the bases aren't identical, but we'll use the same solution process. We'll just take the natural log of both sides, ln of 53, and by the law of logs we can pull x out in front and we get ln of e. X ln of e is greater than ln of 53. But ln of e is just 1, and 1 times x is x, so x is greater than ln of 53. And we're done.